Let's talk about Ohm's Law. So consider our basic resistive circuit from last time. We just had one DC voltage source that we connected to one resistor. So remember, this longer bar corresponds to the positive side of the DC voltage source, and the shorter line corresponds to the negative side. And then we had a current that originates from the positive, goes through the resistor, and comes back to the negative. And that's the current. We don't know what that current is, but we do know that the voltage that's supplied is 1.5 volts, and we know that the resistance is 100 ohms. So let me make a note just from a practical perspective. There is a little bit of resistance that's in the wires. Wires are generally made with materials with high conductivity, so the resistance is so low that we consider it to be negligible. So we don't worry about the resistance that's in this wire. We're just going to consider all the resistance to be present here in this resistor. Now, the voltage, current, and resistance are related to each other by Ohm's law. V, I, and R are related to each other by Ohm's law. Ohm's law states that V is equal to I times R, right? Nice and simple. I will make a note though, in some texts, instead of a V, you might see an E. That's kind of an older notation. Usually you'll see a V. Now, this is actually a linear relationship, and the reason why it's kind of like y equals mx plus b, where you can think of the V as like the y, the I is like the x, and the R is like the M, with a B equal to 0. And the reason why that works is because R is always going to be constant, and that's because R is a linear circuit element. Okay, so for our example above, we have that the voltage is 1.5 volts, and we have the resistance in the circuit is 100 ohms. So then we can say, by Ohm's law, we have that V is equal to IR, so that implies that I is equal to V over R. The voltage in our circuit is 1.5 volts. The resistance in our circuit is 100 ohms. So we take 1.5 and divide by 100. We get 0.015 amps is the unit of current. This can also be stated as 15 milliamps. So that means that we have 15 milliamps of current that is originating from this voltage source and flowing everywhere in this circuit. So there's 15 milliamps that is flowing through this resistor, because there's only one path that the current can take. So if we know that the resistance of this resistor is 100 ohms, we know that the current flowing through this resistor is 0.015 amps. We can do another Ohm's law calculation kind of locally at this resistor, and you'll find that the voltage at this resistor is 1.5 volts. Now let's discuss this conceptually. We have a voltage source that is connected directly to the resistor. Now remember, we think of voltage as the push it requires to push the current through the resistor. So that energy that gets dissipated at the resistor that's required to push the current through, we refer to that as a voltage drop. Okay, so I'll just say voltage drop. Okay, so the voltage drop is kind of, you can think of it as the voltage that is burned up, right? The energy that's burned up in pushing the current through this resistor. and it turns out that that energy is actually dissipated in the form of heat. And when you go to make circuits in real life, if you were to touch a resistor, if there's current, high current that's flowing through it, it will heat up. So this is an example of basic Ohm's law through a basic resistive series circuit with a DC voltage source.